Hello everyone, I'm Yusuf Sulistionugroho from Nara Institute of Science and Technology, Japan. In this opportunity, I would like to present my journal paper entitled How Different Are Different Diff Algorithms in Git. In empirical software engineering research, diff is commonly used in various topics. Along with the growth of GitHub, recent studies analyze software changes extracted from Git repositories by using the git command, for example, git diff. But do you know that according to Git diff documentation, Git offers diff utility for users to select the diff algorithms, either Myers, minimal, patience, or histogram. In textual differencing, all diff algorithms are computationally correct in generating the diff outputs. Without specifying the algorithm in Git diff command, Myers is used as the default. However, the problem is that the diff outputs are sometimes different due to different diff algorithms. Different diff algorithms might identify different change hangs, that is, a list of program statements deleted or added contiguously, separated by at least one line of unchanged context. The figures illustrate two diff outputs extracted using two diff algorithms, that is, Myers and histogram. As we can see in the example, there are two differences. The first one is the number of the change lines and the position of the change lines. In Myers diff output, we see 9 added lines of code from line 5 to 12 plus line 16 and 2 deleted lines of code between line 18 and 19. While in the histogram diff output, we see 4 deleted lines of code from line 5 to 8 and 9 added lines of code in line 9 and from line 13 to 20. To clarify the impact of adapting different diff algorithms on empirical studies and investigating which diff algorithm can provide better diff results that can be expected to recover the changing operations, we carry out two sequential analyses, systematic mapping study and empirical comparisons. For the systematic mapping, we collect from 3 high-ranking journals and 8 top international conference proceedings that was published from 2013 to 2017. Out of 3,057 papers, we mapped 52 selected papers to understand which diff algorithm is used in previous studies and the purpose of mining Git repositories. The results revealed that all collected papers had never considered the other advanced diff algorithms. We also found that the purposes of using the git command were to get patches, followed by matrix collection, and bug introducing identification using SZZ algorithm. Based on these top 3 popular usages of the git diff in previous studies, we conducted an empirical analysis to compare the diff outputs generated by 2 popular diff algorithms, that is, Myers and histogram. We applied the 2 algorithms in 3 applications, collecting metrics and identifying bug introducing changes using SZZ algorithm, and manual comparison on patches. The results show that the percentage of files having a different location of identified change lines of code are 4.17% and 4.62% on average in the application of matrix and SZZ algorithm respectively. Considering the commits, we found that the different location of the change lines of code accounting for 7.79% in matrix and 9.68% in SZZ application averagely. The result of our manual investigation on patches shows that the histogram algorithm provides better outputs compared with the Myers in describing the code changes from the source code files. But they have almost the same ability to extract the diffs from the non-code changes. For example, the changes of a text file. Our quantitative analysis have shown that the different diff algorithms can report the different amount of change lines and identify different change locations. Our qualitative investigation reveals that histogram is better for describing code changes. Since diff is the fundamental tool for various software engineering tasks, considering the limitations and advantages of algorithms is important. Thus, currently we recommend using the histogram algorithm when analyzing code changes. Our study provides new knowledge in the field and has been referenced to the actual tools. For example, the first one, in Git extension, and the second one, it has been implemented in PyDriller. Now the PyDriller users can consider histogram algorithm in their experiments. That's all. Thank you.